All right, day one of unit second to last, unit 11. There's several things sort of thrown into this unit. It's hard to give it a title. Just call it unit 11. First day is solving separable differential equations. That's a mouthful. So let's just back up to algebra land. Let's solve this equation for y. This is not calculus, but it is related to what we'll do today. So right up there at the top, a little warm up to get our brain going. 3x plus 4y minus minus 7 equals 3y minus 5x. Solve that for y. Ready, go. Let's see. Subtract the 3y over, subtract the 3x over, add the 7 over, and y equals negative 8x plus 7. And you're like, well, what the heck does that have to do with calculus? It does, because some of the steps we just took, as basic as they were, will be very similar to the steps we take in these complicated calculus things that we do. So we'll refer back to this problem in a minute, because it makes things a little easier to understand, I think. Okay, the solution to any differential equation is a function. The solution to dy dx equals f prime of x. Think about this. In the library of things that you can do to both sides of an equation, like up here you added things to both sides and subtracted things to both sides, and later in your math life you learned that you could square both sides or square root both sides. You can also take an antiderivative of both sides. And so if I antiderivative the derivative, what do I get? What's the antiderivative of dy dx? What is it? Just y. And what's the antiderivative of the derivative of f? F of x. But there's one extra thing on here we have to be careful about. Plus c. When you antiderivative, the plus c shows up. And I guess you could put it on either side, but since we're solving for y, we usually put it on the not y side. This is called the general solution because of that plus c. Like there's more than one answer depending on what c is. Or at least right now there's an infinite number of answers. The plus c makes it what we call a family of solutions. Meaning until we know what c is, they're all related, family. They just have different plus c's at the end. Now, in most questions, we've seen this with position and velocity, we give you an initial condition so that you can figure out what c is. And that will continue today. We won't be doing position, velocity, acceleration, but it's sort of the same in that you take an antiderivative, a plus c shows up, and you got to figure out what the c is. When you know what c is, then you have the particular solution. So general solution has the plus c. Particular solution is when you know what c is. So that is solving a differential equation. Now, there is an entire college course devoted to this called differential equations. A little side note for you guys that will pursue the math science thing in college. Cal 1, Cal 2, Cal 3. Cal 1 is calculus AB, that's what you're doing now. Cal 2 includes, or Cal BC is 1 and 2. Then you do Cal 3, and then you do differential equations. So you get a whole semester over what we're going to spend a day on. So obviously we're going to get just a really, really, really small piece of the overall differential equations. And then even after that comes partial differential equations. And that's as far as you have to go for an engineering major. So there's your future, some of you. Okay, that was just a side note. in this course, what makes us able to only do a couple days worth rather than a semester's worth of junior level math stuff is that everything we do will be a separable differential equation. And the separable is what makes the problems, I shouldn't say easy, that's way too generous. What makes them possible, what makes them easier than the rest of them. A separable differential equation can be written in the form f of y dy equals f of x dx. Very informally, you get your y stuff on one side and your x stuff on the other side. That's the algebra part of the problem. That's why we did that warm-up at the very beginning. You put all the y stuff on one side, all the other stuff on the other side. That's kind of the same. That's the first step of solving a separable differential equations. Separable meaning we're going to separate the x's and y's. That's the separation part. Which means, yes, later in life, like a couple years from now, there'll be ones where you can't separate the x's and y's, and that's why you don't do those until junior year of college, after you've taken 3 semesters of calculus. To solve a separable differential equation, separate the variables, then integrate both sides. And maybe it seems dumb to put this in a box, but separate, then integrate. Separate, then integrate. And the good news about separate and integrate is almost every time one of these shows up on a free response question on the AP test, you will usually get a point just for separating. It's like, an Algebra 1 student could do that. Like, get all the X stuff on one side, get all the Y stuff on the other side. Congratulations, that's 1 point on the AP test. Not like 1 out of 5 points, but like 1 point on that FRQ. And then integrate is maybe 1 or 2 more, and then find C if you need to. But the main thing is you get a point just for separating. So we encourage you, separate first, then integrate. It's an easy step. I think people try to skip it, and then they mess up the integration because they didn't show the separate step. Okay, let's try some. Separate, then integrate. That's the theme of today. Number 1, solve the differential equation x squared plus 3y dy dx equals 0, given that the point 0, negative 4 is on the graph of the function. Okay, so we'll separate and integrate, and then we'll use this to find C. So we'll use that, but not till the end. Okay, so I want all my x stuff on one side, all my y stuff on the other. So let's subtract the x squared over. And I guess like all algebra stuff, you're going to get to the point where you don't show a whole lot of algebra stuff. You definitely need to show the separated equation, but you might be able to get there pretty quickly. This is our first one, so I'm going to slow it down and show all the steps, just like we were solving that warm-up, on day 1 in algebra. So subtract x squared over. And then this next step is kind of a little bit fuzzy, because we're going to multiply by dx. I almost shouldn't say it's fuzzy because it's fine to do. It's just dy dx is usually one thing, and now we're going to separate it up. The dx's cancel. So I've got 3y dy equals negative x squared dx. Now they're separated. So there's partial credit right there. Haven't really even done anything. All right, next let's integrate both sides. careful, the left-hand side we're integrating with respect to y, the right-hand side we're integrating with respect to x. So one step at a time, but we can pick on pieces of this. Autumn, how about the antiderivative of 3y? Yes.
Yeah, I forgot what it was called.
Yes, y to the 2. It's accurate. It was y squared. Yes, so increase the power, divide by the new power, 3/2 y squared. Caden, how about the other side? What's the antiderivative of negative x squared?
Negative x to the third over 3.
I would say sort of to that answer.
Plus c.
Plus c. Now, it doesn't matter which side the plus c goes on. So if Autumn had put plus c over here, it wouldn't really be wrong. But since we're usually solving for y, we almost always put the plus c on the x side. Okay, so that's my integrate. But now we need to figure out what c is. And we said earlier that all solutions are a function. So I need to solve this for y. Okay, I've got options here. I'm going to do it the normal way first because I think that's the easiest way. Sometimes it's beneficial to solve for c like right away. Other times it's better to solve for y and then figure out what c is. Most of the time we want to solve for y and then worry about c. So let's multiply by 2/3 to fix the 3/2. So y squared equals, now I've got negative 2/9 x cubed. So I'm multiplying through by 2/3 to cancel the 3/2. In some sense, no, in every sense, the calculus part of this problem is over. Like we separated, we integrated, we're done with calculus. Now it's an algebra problem, solving for y, figuring out c. Okay, we're going to pull a little trick here. 2/3 times c can just be c. Do you know why that is? Like, that's not right. We haven't figured out what c is. So if c is any number, because we haven't pinned it down yet, then 2/3 times any number, that's still just any number. So if you're multiplying or even adding, like you can still just call that c. Now, those are different values, but we haven't figured out what it is yet, so it doesn't really matter. All right, now let's use our point. Well, you know what? Let's solve for y first. So y equals square root both sides. Be careful, though, when you square root both sides. What are you supposed to do? Algebra students? Plus or minus. Okay, but something funny is going on here. I'm supposed to have a function for an answer. If I do plus or minus, that means I've got two answers. So I'm going to have to pick the plus or minus in a moment. Let's figure out what c is. So let's use 0, -4. So -4 goes in for y. -2/9. 0 cubed plus c. Well, I think I know the plus or minus situation. So regardless of all that, which sign am I going to have to use to get -4 for an answer? I need to use the negative. So throw out the positive one. The answer is going to be negative. Now let's figure out what c needs to be. So I could square both sides, or I could multiply both sides by negative. C is going to be 16. however we want to get there. So y equals negative square root negative 2/9 x cubed plus 16. Separate, integrate, solve for C. So I'll just put that as in our box up here, because we'll almost always solve for C. And I'm on a 20-year-long quest to find something that rhymes with separate and integrate that means solve for C. So if you come up with some silly word, I will entertain it. The best one I've heard so far is, if I can remember how to spell it, separate, integrate, and algebraificate. Or maybe just algebraicate, I don't know. Separate, integrate, solve for C. That's the steps every single time. And usually it's the integrate step that's calculus. Everything else is algebra. That's this. Separate, that's algebra. Integrate, that's obviously calculus. And algebra is algebra. Number 2. Let's see. Why don't you separate? See if you can separate that, and then we'll worry about integrate. Okay, so multiply both sides by 2y. Multiply both sides by dx. You guys showed various amounts of algebra while you did that. Some of you showed everything, some of you showed nothing. That's fine. Eventually you get 2y dy equals negative sine x dx. There's our separate step. Congratulations, you get partial credit just for knowing a little bit of algebra. Next, let's integrate both sides. Lost it. Oh, Johnny. Find somebody who's here today. There we go. Okay, Alex, what's the antiderivative of 2y dy? It is y squared. Aslan, what's the antiderivative of negative sine? Nice. Cosine of x plus c. Okay, so let's solve for y, and then let's solve for c. So y equals, we're going to have that same issue we had last time, plus or minus cosine of x plus c. And this is kind of weird because it's not plus and minus like when we use the quadratic formula, like you keep both of them. This really is plus or minus, like we have to pick one. Let's use our point. So y is 2 plus or minus square root cosine pi over 3 plus c. So I think I can tell already. Lexi, am I going to be using the positive or the negative?
Positive.
The positive, because if I want my answer to be positive 2, I'm going to use the plus one. Okay, then I need to know the cosine of pi over 3. Maybe you have it memorized. Maybe you need to do a quick little sketch. Either way, what's the cosine of pi over 3? 1/2. So 1/2 plus c. And at this point, some of you are going to figure out c in your head. Others of you are going to show the algebra steps. It's fine either way. Square both sides. So c needs to be 3.5 or 7/2 or 3.5, however you want to say it. Okay, so I'm kind of done with the math, but when it says find the particular solution, it means I need to write the answer. I haven't really done that yet. So y equals square root, the positive version, of cosine of x plus 7/2. Separate, integrate, algebraificate. All right, number 3 looks a little bit more challenging, maybe. What do you want to do first to separate on number 3? Yeah, let's subtract that e to the x over. Oh, then the negatives will cancel, so that's nice. And then let's just multiply the dx over. So e to the y dy equals e to the x dx. There's our separate step. Congratulations. Partial credit already achieved. Then we'll integrate both sides. Oh, and whoever goes first here, I guess, gets the easier version because it's kind of the same thing. I mean, whoever goes second gets the easier version. Then, that means you're going first. What's the antiderivative of e to the y dy?
E to 2y over 2.
Nope, it's easier than that.
E to the y.
E to the y. The derivative of e to the y is e to the y. The antiderivative of e to the y is e to the y. So, Jace, what's the antiderivative of e to the x? You want to say a little bit more?
Plus c.
Plus c. So let's natural log both sides. I wouldn't say multiply by natural log, but let's natural log both sides to get y by itself. So yeah, now we're in the algebra phase. So separate, that was algebra. Integrate, that was calculus. Now it's back to algebra. So let's natural log both sides. Whoopsie, the x plus c. And the reason we do that is y equals, right, the y can come down front. I can't really do that on the other side because it's e to the x plus c, so I'm kind of stuck with that. Okay, let's use 1, 1. So 1 goes in for y. 1 goes in for x. Okay, there's some fancy algebra we could do to solve for c, but can you figure out what c needs to be to make this work? Some of you are showing me the answer. What's the natural log of e? 1, so what does c need to be? 0. So that means y equals natural log e to the x plus 0. This problem is getting easier as we go now. What's the natural log of e to the x? The x can come down front, and the natural log of e is 1. So that was a weird question to land at y equals x. Number 4. They keep getting harder. I can't just say, here, you try it. Let's separate first, so that part's easy. dy over y equals negative 2x dx. Again, please show that step. That gets you a point on partial credit and on the AP test. Patty, I'm going to give you, I think, an easy question. What do you want to do next? I'm not even asking you what the answer is. That's the separate. What do we do after we separate? Integrate. You're welcome. And then now we can get some help on antiderivatives. Justin, do you remember the antiderivative of dy over y?
Is it, what can I guess? Is it y to negative y squared over 2?
Okay, so you're thinking about power rule. And if you use the power rule, if you increase the power by 1,
To be y, just y?
you get y to the 0, and then you divide by your new power over 0. So this is the spot where the power rule doesn't work. So it's the only spot where the power rule doesn't work, and if the power rule doesn't work, hopefully you remember that this... All right, somebody help him out. Do you remember what's the antiderivative of dy over y? Natural log of y. Jameson, how about the other side? What's the antiderivative of negative 2x?
Negative x squared plus c.
Negative x squared plus c. Okay, our calculus day is done. Now we are on to algebra world. Ambria, what do I do to solve that for y? Any idea? This goes back to algebra 2, maybe? How do I, undo this natural log? What's the opposite of natural log? E. So there's two ways to think of it. You can either e to both sides, or you can do that fishhook thing. E to the negative x squared plus c equals y. I'm going to just write that differently. Y equals... Okay. Another way to write this is, again, this is all algebra stuff, would be e to the negative x squared times e to the c.
Wait, why? Does that say equals y on the top or equals?
That says equals, sorry. Right, like if you had x to the 5 plus 2, you could rewrite that as x to the 5 times x squared. Like we never go that direction with it. But we are here because this is going to make life a little easier. E to the c. C could be anything. I haven't figured out what c is yet. I haven't assigned or figured out what value to use. So e to the c, I could just make that a different c. We're doing algebra tricks here. It's not calculus, that's algebra. Seth? Yes. So c can be anything, right? So that means e to the c could be anything. So rather than mess with e to the c, it would be a whole lot easier. This would be a different c, a different value. So some people label it different. Just it looks better to have a constant out front rather than dealing with e to the c. This step happens a lot. In fact, all of this problem happens a lot. Where you get natural log, you e to both sides, and you do this little trick. And it makes life a little easier later. Alright, so 5 goes in for y. Zero goes in for x. They did us a favor here. What's e to the 0? 1. So c is 5. So y equals 5 e to the negative x squared. That one deserves the... Haven't used the stamp in a while. Calculus wasn't really bad on that one. That was way back here. Not too bad. There was a whole bunch of algebra after that. Last one. Find the particular solution. Y prime equals 3y plus 6. Given that, I'm going to rewrite that as a point just because that's how we've been seeing it. this looks a little bit weird. How can I, well, what's y prime, I guess? Let's start there. dy dx. So I can't really separate x's and y's until I have x's and y's. So let's rewrite y prime as dy dx. Now I need to separate out the y's and x's. So how do you want to get y's and x's on different sides? I guess, you know what, how do you want to get dx off of dy? Let's do that side first, because I think that will help. Let's multiply by dx. So dy equals 3y plus 6 dx. Okay, what would you like to do now? Okay, we have options, but that's a good one. You can't subtract 6. That's the sort of the trick, or people try is like, let's subtract 6 over. But I need to divide by 3y plus 6. There's one other option that might make life easier later. If instead of dividing by 3y plus 6, if I factored out the 3 and divided by y plus 2, it's going to make my antiderivative a little bit easier to deal with. That way, rather than having 3y plus 6 in the bottom, I only have y plus 2 in the bottom. And I've still got the 3, but I'd much rather the 3 be attached to the dx than the 3 be in the denominator on the y side of things. So, Ben, what you said was right and would work. This is a little bit of a cheat code to make our lives a little easier. Now it's time to integrate. Give Abby the hard side. Kenneth gets the easier side. Abby, any idea the antiderivative of dy over y plus 2? It's related to number 4 that we just did. Good. Natural log, absolute value, y plus 2. Now, Abby did that without u substituting, or maybe she did it really fast in her head. But if you needed to, you can do the u substitution. It's a pretty easy one. But you land at natural log of y plus 2. Kenneth, how about the antiderivative of 3 dx?
3x plus c.
3x plus c. Somebody who's here. Talk about this is similar to what we did last time. What do you want to do next to start to get y by itself?
Can I cancel out an absolute value by taking the absolute value of the other side as well?
No, can't do that. Let's get rid of this natural log. How can I undo a natural log? Let's do the fishhook thing. It's a little more complicated this time. E to the 3x plus c equals y plus 2. Oh, here's our little algebra trick. What can I do with e to the 3x plus c? Just going to rewrite that as c e to the 3x. And be careful, those are not the same c's, but it doesn't really matter because we don't know what c is yet. If that bugs you, then some people will put subscripts on them to sort of indicate that they're different. So this was c1, and now this is c2. But it doesn't really matter because we don't know what c is yet. So y equals c e to the 3x minus 2. Just plug in 0, 7. 7 equals C e to the. They usually give us 0 on these problems because it makes life easier. Makes life a lot easier because e to the 0 is 1. So if I add 2 over, e to the 0 is 1, I get C is 9. A whole lot of algebra, a little bit of calculus. Right? Each of these problems has like one calculus step. Take the antiderivative of both sides. Everything else is algebra, 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 algebra.
Yes.
Questions?